So today we're going to talk about solving linear systems. And you guys have seen linear systems before, but you've only seen two variable systems. Today we're going to talk about three variable systems. So the first step, what you're going to do is step one, which is basically to rewrite the linear system in three variables as a linear system in two variables by using the substitution or elimination method. Now I'm going to show you that example right now. Let me close this off and bring it down here. So the system that we're going to be using is this guy right here. So 4x plus 2y plus 3z equals 12, and then 2x minus 3y plus 5z equals negative 7. And the last one's 6x minus y plus 4z equals negative 3. So what we need to do is we need to go ahead and figure out how to rewrite that linear system in three variables as a system in two variables. So what we want to do is, I'll make this a little bit smaller, I'll put it up here, is what I'm going to do is rewrite the top one. So I'm going to rewrite it as 4x plus 2y plus 3z equals 12. Now I need to figure out what variable I should eliminate. So I already chose this one, this equation. Now I have to look through this and figure, okay, what's the best equation to eliminate if I add them together? So if you think about it, if I add these together, I'm probably going to go with this one and then this one, because basically I think that's the best option for me. So I'll go ahead and write this down. 6x minus y plus 4z equals negative 3. Now if you look at these values, I want something to cancel out. So if I add 4x plus 6x, that'll give me 10x, won't cancel out. 2y plus negative 1y won't cancel out. 3z plus 4z won't cancel out. So that means I'm going to have to do something to the whole problem. I can either, the best bet is, alright, I'm going to cancel out these y's, but I have to do something to this down here. So if you notice, if I multiply everything by a 2, so if I distribute, and then distribute, you will notice that you're going to get a whole new problem. So I just wanted to rearrange this. I always like to write it right next to it, so I'm going to keep the top one. So 4x plus 2y plus 3z equals 12. And when I distribute, I'll get 12x minus 2y plus 8z equals negative 6. Now when I combine them, this will be my new equation 1. So this will be 16x. These will cancel out, and it'll be plus 11z equals 6. So now that I canceled out the y's with the white equation and then the blue equation, what I'm going to use now is I'm going to use this one and this one to cancel something out. So I'll rewrite those down. So now I'm going to use the same process as we did before to get my new equation 2. So if you notice, if you look at this, what can I cancel out? I can't really cancel out anything, right? This would be 8, this would be negative 4, this would be 9, this would be negative 10. So that means I'm going to have to do something to the bottom one. Now if you notice, if I multiply this one by 3, it won't cancel out. So I'm going to have to use a negative 3. So what I'll do is basically just rewrite my problem right next to it. So this would be 2x minus 3y plus 5z equals negative 7. And then when I distribute the negative 3, I'm going to get negative 18x plus 3y minus 12z equals 9. then just draw a line. And now I'm just going to go ahead and add these up, add them up, add them up, add them up. So when you do that out, you will get negative 16x. These will cancel out right here, so this will cancel out, so this will cancel out, and then I just bring down my z's. So it would be negative 7z equals 2. So now what you have here is you have your new equation number 2. So we have equation 1 and new equation 2. Now basically what you have is you have a system with two variables. So we want to go ahead and rewrite those. We're going to use this guy right here. We're going to use 16x plus 11z equals 6. And then we're going to use the yellow, which was negative 16x minus 7z equals 2. And then you want to go ahead and solve this. So when you solve this, it out, you'll notice that the x's cancel out, and then you get 11z minus 7z, which is really 4z, and then 6 plus 2 is 8. Divide by 4, divide by 4, and you'll get z equals 2. So now that we got z equals 2, you're going to take that and you can plug it back into either one of these equations, this one or this one. I'm just going to plug it into this guy right here. So I have 16x plus 11 times the 2 equals 6, and you'll get 16z plus 22 equals 6. Subtract both sides, inverse operation. You'll get 16x equals negative 16. Inverse multiplication is division, so you divide by 16, and you should get x equals negative 1. And now what I'm going to do, now that I have the z and I have the x, I'm going to plug it into one of the originals up here. So it's totally up to you on which one you want to choose. This one's probably the easiest because I look at it and the y doesn't have a coefficient. So that might be easier to solve for, so I'm going to go ahead and plug that in right now. So I started to plug in the value of the 2, went in for the z, the negative 1 went in for the x, and now I'm just basically just solving it out. So now I have negative 6 minus y plus 8 equals negative 3. So negative 6 plus 8 is just 2. So 2 minus y equals negative 3. Subtract 2 from both sides. I'm just going to do this here. I'm running out of room. And we get negative y equals negative 5. Since there's a negative 1 here, I have to divide by negative 1, divide by negative 1, and you should get y equals 5. So we basically have our ordered pair. It's actually not a pair because there's 3 of them. So what we call that is an ordered triple. So since we have an ordered triple, we had our x value, which was negative 1. We had our y value, which was 5. And then we had our z value, which was 2. So ordered triple just goes x, y, z. Ordered triple. Instead of an ordered pair, it's an ordered triple. Now you can check your answer, take these, and you can plug them back into the other 2 originals, and you'll see that it will work for all 3 equations. And here are the steps for solving a 3-variable system. If you want to go to the book, you can actually go to page 31. That's the actual example I use. So if you're having difficulty with the video, you can go back there and you can go through it on the textbook or on the online textbook. And I'm hoping these diagrams come out a little bit better, which I think they might. I'm trying a new process, so let me know how you feel about the writing. If it's blurry, let me know. If it's good, let me know. And remember, come up with a question, higher order thinking, an example, or a confusion question. And I'll see you in class. Have a good night. Or good morning.